Hello, pre-calculus student. This video is for chapter 5.4, part 3. We're going to be talking about co-functional identities and solving side length of right triangle when we only have one side. Okay, so this is about co-functional identity. It's a new identity in addition to the identity that we mentioned in 5.3. So this which can be illustrated very well in a right triangle only. So let's look at a right triangle. It's not a special right triangle. I have a angle called alpha. Alpha is like the Greek letter. And then this is angle is called beta. One thing that we notice would be if we do SOHCAHTOA, let's say this side length, because it's facing beta, we call it side length B. This alpha is facing, like it's opposite to alpha, we call it A. And the hypotenuse is C, kind of like any right triangle, we say ABC. Now, if I want to do sine alpha, is saw, right? So be opposite to alpha is A over C, this one. And if I do want to do cosine beta, what happened? Ka is adjacent. Oh, so A. So this would also A over C. They're actually equal. Although we are talking about two different angles, but they're equal. So sine and cosine, you can switch the angle and do cosine, they're equal. And the same thing would be if I do sine beta would be B over C, right? And then cosine alpha would be cosine is ka B over C. They always equal. That means if I draw a right triangle here and I do 20-degree, what is the other one? This has to be 70, right? They can only add to 180, so this two has to be 90. So I would have this cosine 20 would equal to the sine of the other one, right? And then cosine 70 would equal to sine of 20. That means in a right triangle, if they're 90-degree sum to each other, you can switch them. So we get this co-function identity that say cosine t, if it's a function, then it would be sine 90-degree or pi over 2 minus t. So it's like if this is 20, then this is 70. So you use 90-degree minus it. And this co-function identities is very clearly demonstrated in the right triangle. And if you use sine and cos over cosine to do this, it's valid for tangent, it's valid for secant, but the other one that's equal is cosecant. For tangent, the other one that it's go with it is cotangent. So co means complement. So you know that if they're co each other, they are 90-degree the same. Okay, if you switch them 90-degree, yeah, let's do two example. So remember, cosine would co with sine, tangent is cotangent, secant is cosecant. Okay, so if I have sine 40, what would it be equal to for cosine? What angle would it equal to? It would be 90-degree minus 40, right? Is 50. So if you put in the calculator for sine 40, it's exactly cosine 50. Meaning, if I have to evaluate sine 40, but I don't have the sine table or the sine button in the calculator, I can just do cosine 50. Or in calculus, most importantly, if I don't want to do sine, the function is difficult to manage, I want to switch it to cosine, I can switch it to cosine 90-degree minus the original. For example, if I have tangent pi over 6, its co-function is the cotangent, so I would do pi over 2 minus pi over 6. It would equal, they will equal. So this would be 3 pi over 6 minus pi over 6 is 2 pi over 6, equal to 2 pi over 6 and equal to pi over 3. So tangents pi over 6 would equal to cotangents pi over 3. Okay, you also should notice it in the unit circle. So with this in mind, we can solve for, oh no, okay, with this out of the way, so we have one additional identities. Now we're into the next topic is if someone gives you a right triangle and only one side and one angle instead of two sides, we want to solve the missing sides with the two missing sides. Usually, if it's a right triangle by the Pythagorean theorem, we have ABC, right? A, BC, we can only solve one side if we have both A and B, C, or if we can have C and B, then we can solve for A. With one angle known, it turns out that we can use the SOHCAHTOA definition to solve two missing sides if I only know one side. But you need one additional angle. So how? So this would be solved by Pythagorean theorem. For example, if I know 2, 3, what is this? Then you use Pythagorean theorem, right? You don't need angle. But if you only have one side but one angle, you can use those. So let's just look at this angle. This is 65. I want to solve for A. So I would look at A and 10 because this is the only one that's given. So relative to 65, this is H hypotenuse, right? Relative to 65, this is what? This is a O, right? Equal to O. So for if I have O, what function do I use? So I'm going to write SOHCAHTOA. O and H is sine. So I would write out sine 65 is equal to O, which is A, the missing one, and H is. So this is an equation that has only one unknown. I can solve it by multiplies 10 on the both sides. So A would equal to 10 times sine 65. So you go to your calculator and turn it on. 10. Okay, make sure your mole is switched to degree because you when solving triangle, this is a degree mole. And then you say 10 times sine 65. And then we'll get the other side, 9.06. Let's do two decimal place. A equal to 9.06. That is A. What about B? So I'm going to use another color. Use green. So green, so B 10, 65. So this relative to 65, this is A, right? Relative to 65, that's O. So so I have A and H. A and H car. So I would say cosine 65 is equal to B over, when I say A, it should be adjacent, okay? B over 10. So again, to solve for B, I times 10. 10 cosine 65 would equal to B. So I'm going to put in my calculator. 10 times cosine 65, 4.23. B equal to 4.23. So that's how I solve missing side. I have another one. Okay, so I know this angle and I need BC. This is the one that I know. So I'm going to circle this. This is always an A, right? Because it's adjacent to it. And then B. Adjacent, and then do you feel that this is O? Yeah, O. Adjacent and O is TOA. So I'm going to set up tangent 81 degree equal to O over A, B over 16.5. TOA, right? So times B, 16.5 on both sides. We cancel out the 16.5 equal to B. So multiply the calculator. 16.5 times, what was it? Tangent 81? Tangent 81. 104.18. Oh. B equal to 104.18 equal to B. And then what about, let's do green. So I'll circle this again, but now I do this. So this is hypotenuse. So A and H, so it has to be car, right? Cosine 81 is equal to car A over H. Now this is more difficult because the number is not here, but I still times h on both sides. H cosine 81 degree is equal to 16.5. But to find h, I have to divide one more step, divide 81 degree, divide cosine 81 degree. So h is actually not multiplying, but dividing. Sometimes it happens if your unknown is in the denominator. 16.5 over cosine 81. Yep. 16.5 divided by cosine 81. Right? 105.48. 105.48. There, I solved both sides using one angle and one side. So in the next video, we'll talk about 1, 2, 3, 4, 5 work problem. Okay, we would use the same skill that we have in these videos, solving missing side using one side and one angle.